Hi, good morning, everyone. Can you guys hear me properly? Do I need to turn it up? All good, okay. Good morning, everyone. There are some seats in front here, actually quite a few. So if anybody wants to sit down and listen to the session, this is a good time. There's quite a few seats open. My name is Martin Miller. I'll be moderating the panel for today. The panel is called Leveraging Cloud to Accelerate Unmanned and Autonomous Systems Mission-Critical Capabilities. First of all, I'd like to thank all the organizers that helped make this kind of panel happen. Number one, that goes out to the AFCEA organizing committee. Number two, the AWS folks who helped organize the actual panelists being here and all the talking points. And then number three, the audio-visual team that puts together the mics and sound team and kind of makes this all run so smoothly. As you may know, Amazon has a set of leadership principles. These principles act as guiding tenets in our actions and decisions. Before we dive in, I'd like to share one of Amazon's leadership principles that feels particularly relevant to our discussions today. And that's the leadership principle, think big. And it goes as follows. Thinking small is a self-fulfilling prophecy. Leaders create and communicate a bold direction that inspires results. They think differently and look around corners for ways to serve customers. Each one of our esteemed panelists here has, in their own way, embodied that spirit. Today, we will delve into implementation strategies on how to give the US military a technological edge. I encourage you, the audience, to use that think big mindset in your own discussions across AFCEA as you walk around the rest of the week. Okay, now I'll do our introductions. I'll also say that when you get a bio from each one of these individuals, it's quite lengthy and they're all extremely well accomplished individuals. Having said that, I cut it down to kind of a smaller redacted version. Rob Nolan, sitting right here to my right. Rob Nolan is AWS's Chief Technologist and Senior Principal Architect for US Defense Programs, where he has supported cloud initiatives across DoD components since 2017. Drawing from over 20 years of commercial industry experience, he specializes in infrastructure architecture and cybersecurity, focusing on advancing AWS solutions to enable mission outcomes through cloud technologies. Rick Jack is second to my right. Rick Jack is a distinguished C4 ISR software engineer at NIWC Pacific, where he leads Navy digital transformation initiatives and serves as infrastructure pillar lead for Project Overmatch, bringing over 25 years of C4 ISR systems experience. He started his career as a Navy data systems technician, where he now guides teams in implementing DevSecOps and modern software architectures. Rick Jack has a Master's of Science in Systems Engineering from Naval Postgraduate School, along with a Bachelor of Science in Computer Science. Third is Zach Kramer. As General Manager of Mission Command Connected Warfare at Anduril, Zach Kramer leads the development of Lattice, a command and control data mesh system that enables connected warfare at the tactical edge. Prior to this role, he spent over 20 years at Microsoft leading efforts to deliver Azure cloud services to the US government across all classification levels. Fourth over, Alan McAfee. He serves as the CTO of Fuse, where he leads development and product lines focusing on user-centric design principles and aligning development efforts with customer requirements. His diverse background includes serving as Vice President of Engineering at Robo3D, managing the MIT Center of Bits and Atoms Fab Lab in San Diego, and serving 6 years as a Navy corpsman with combat experience along the 1st Marine Division in Iraq. And then last but not least on the end is Alex Zimmer. Since 2018, Alex Zimmer has specialized in UUV systems, focusing on advanced sensors, autonomy, and automatic target recognition while leading the UW-EOD Artificial Intelligence Program. He serves as the MK-18 UUV representative for key international partnerships, including the US, UK, Mine Countermeasures KMO 2.0 and AUKUS Pillar 2 initiative, along with Project Ammo. Okay. Now, on to the questions. So we're actually going to start it out kind of light. I have an introductory question. I kind of want to start all the way down at the end. Question is as follows. If you could pick one science fiction movie or book that best represents the future of autonomous military systems, what would it be and why?
Yeah. Excuse me. So my favorite science fiction series is actually Dune. And so those of you that know Dune, essentially one of the antagonists is artificial intelligence. In fact, earlier in this series, there is a jihad against artificial intelligence and thinking machines. So it's kind of ironic that that's my choice here. But I think that in the future, we're going to see robotic autonomous systems, autonomous military systems act in certain ways that are not antagonists to our U.S. military chain of command and our intent. I think that autonomous military systems of the future are going to continue to serve us in the dull, dirty, and dangerous realm. They're going to become more intelligent, but operate within the boundaries that we set forth to them. And they're not going to become these overarching, intelligent thinking machines that are set out to destroy humanity. So that's my pick.
Awesome, thank you. Next, Mr. McAfee.
Yeah, so I went a little less dystopian. Mine's a Ghost Fleet. I think it's a little more relevant, it's a little more near term, and I think it speaks a lot to the vulnerability of legacy platforms and near peer threats right now, and it's a good roadmap to understand if we were to be outmatched, what we could do to come back, and how we could integrate a lot of this new bleeding edge technology into assets we already have. So we don't need to go out there and spend a whole lot of money to keep pace. So it's a good book, you should read it.
One that came to mind for me was Ender's Game, actually. As you take a step back, it raises all these kind of interesting questions about how you pull back and control systems that you may not have direct line of sight and command and control over. And so creating how we continue to have human ingenuity in the loop of these decision making, even when we may have autonomous things out carrying out the actions. And so thinking through what those implications are and how they apply to the work that we're doing really is intriguing to me, because I think that's one of the root questions that we have to answer is how are we still in control of these systems?
So I guess I'm going a little deeper. I'm going way back to the 90s. I like anime, and The Ghost in the Shell to me was a pretty awesome series. And why I picked it was because the intertwinedness of machine and man was a key component of that movie or that anime cartoon. It was in the mid-90s when that came out, and it was kind of forward-thinking relative to how humans would interact with things like cyborgs, and you could take cyborgs and make them autonomous vehicles or anything like that. But the key thread of that movie that made me think about this was the idea that cybersecurity was a core element of this. The idea that you could seed in and change the behavior of these things to do nefarious things was something we should always think about relative to the future of autonomous warfare and cybersecurity.
Alan stole mine, so I had a cool talk track around Ghost Fleet, but I would probably say Ready Player One is another interesting way to think about it, because when you look at the over-reliance on technology in Ready Player One, how everyone kind of lives in this alternate universe, we have to kind of realize that the technology is super important. I think we're going to talk about a lot of benefits of it today, but ultimately, you have to actually touch grass and look outside and realize the world still exists around you. And so making sure that we don't over-rely on these things, and we build in safeguards and we build in the right understanding of what it's doing for us is going to be super important.
Awesome, great suggestions. It seems like each one of those had a very futuristic take on it. So the next question is going to be more government focused, or at least that's who we wanted to get the insight from Rick Jack and Alex Zimmer. The question goes as follows. In developing autonomous systems, how do we balance the need for technological standardization with the advantage of having diverse and unexpected capabilities that could surprise our adversaries? Rick Jack, you want to kick that one off?
Sure. I love this question because there's always a trade space discussion and how you innovate. I call it a dichotomy between standards and innovation, or the broad sprawl of opportunity that presents us with autonomous vehicles, is an important question we need to keep asking ourselves. So if we look at the tenets of what standardization brings us, it's first and foremost interoperability. I think interoperability is a core element of how we're going to get after being able to do what we have to do. I would imagine the second part is predictability. Without standards, how do we know how things are going to work? We have to be able to trust these autonomous systems as we integrate them into the system. And then control. Like if we don't have an idea of how we're going to do standards control, that's going to be a big issue. But on the other end of the spectrum, if we talk about how we're going to compete, there's an asymmetric advantage to a broad spectrum of capabilities. We can't discount that. Innovation happens at the seams, not in the core. So we have to embrace opportunity as it presents itself with all these systems. I think Ukraine brings a great example of that. So if you ask yourself, how do we balance the two? I would say you'll always lean towards modularization. So the idea that you have to have abstraction points and know what's important and focus on the standards that make these things interoperate and control together is probably where I would lean most towards. So modularization, and then the idea that we have to test and iterate. Being agile is also part of that idea of how do we balance these two things.
Awesome, great answer. So I like that answer because essentially you can do standardization with modularism, but at the same time maintain flexibility.
Yes.
Alex Zimmer?
So I think the key to the question is how do we surprise our adversaries but not ourselves, right? So we want to bound the autonomy. I guess I'll circle back to that in a moment to give you some context on my role. So I essentially am in charge of an artificial intelligence program for unmanned underwater vehicles. And these robots operate underneath the waves in an austere environment with a lot of pressure, a lot of corrosivity around it. There are thermoclines, haloclines. It's hard to see, it's hard to communicate. And so there is an inherent need for autonomy. And then to kind of round this off, there are over 200 Mark 18 vehicles fielded out there today that are being used actively by the fleet. So it's a system that's in place that's actually successful. It's being used today. There's a speaker yesterday that was talking about command and control as a term, and that those two terms mean different things. Control is the idea of having human hands on a joystick, pointing a UAS somewhere, trying to do something with it. Command is the commander's intent being distributed down to it. So what I'm getting at here is I think when we have this technological standardization, we want to have balance in the systems. We want the systems to operate under the commander's intent, but not necessarily have direct feedback loops, pointing those systems in the right place. They need to be able to think to that degree by themselves. That being said, in the future, you're going to have these unmanned systems across every domain, undersea, in the air, on the ground, and you need them to talk together. And so, you do run the risk of unexpected behaviors, or essentially calling emergent system behaviors that come out of that environment, and those are good things. We address those as they come up. That's part of the innovation process. We could fold those into tactics and adapt the systems. So I don't think necessarily, at the end of the day, we have to have our systems talk together. They have to have common data formats, common languages. We shouldn't force that down to the vendors and standardize at that level, but having that common layer of transportation for communications is important. And then any emergent system behaviors, unexpected capabilities that come out of that is fine. We can use that to our advantage.
Awesome, thank you. So the next question goes to our industry folks up here on the panel. Rob Nolan, Alan McAfee, and Zach Kramer. The question goes as follows. In the context of autonomous systems, in what ways should we be thinking about replicating, assisting, or replacing the human decision-making process? Does this require any new paradigms of operational thinking? So let's kick it off.
You're going to start from the right. Yeah, so I think in the context of replacing, augmenting, it really depends on what level we're talking at. If we're talking at the strategic level, definitely humans need to be more in the loop. It's going to be a slower decision-making process. As you get closer to the edge, in the tactical environment, it's going to be mixed. You're going to have, especially when we're talking about the decide and act aspects of the OODA loop, those are going to become more and more collaborative with these autonomous systems, but a human should still be there when we're making the decisions on what we're going to be doing. So as far as paradigm shifts go, again, I was 20 years ago in Fallujah, so it was a very different environment back then. We had the AeroVironment Ravens, so we could observe, but everything else is still a completely human-driven process. And now as we're moving into the future, it's very cool to see, especially Andor blow up and all these really amazing systems start to get fielded and tested. But I recognize that the young sailors, Marines, soldiers, airmen out there are still going to be challenged with how they're going to manage, monitor, and trust the systems that we're fielding. And that's going to take a pretty big shift in the way we train. Because by the time you get to that engagement layer, that's going to be a very fast-paced cycle. There's going to be most of the autonomy is going to be at that layer, and there's going to need to be very specific controls in place. So yeah, there's definitely going to be some paradigm shifts.
Yeah, absolutely. As we think about it, I think there's several things. So first is autonomy can really enable people all the way at all echelons to be able to carry out their intent more effectively, right? And so one of the things that we've looked at Andoril is, right, how do you simplify the interfaces and allow autonomy to allow you to say, I need to go monitor this vehicle, and instead of having to have someone who knows how to control, steer, and fly, the thing can do it itself. So it's autonomy at the ability to carry out an action. It's not at the autonomy to come up with what the action is. And so all of this is about how we then bring that data back and fuse it together so you can begin operating and making those decisions at machine speed. So if you again use the example of something that's flying, if I don't have to say steer to the left, steer to the right, do those things, it can actually go and execute and carry those out. You can carry that up through all the different strategic levels of warfighting as we look at it. So how do I then have those things working in concert? But again, I'm still expressing the intent of what they need to go do and the outcomes that need to be achieved. And then a big portion of that is data acquisition and data understanding. So the previous question where you talked about how do these things communicate with each other, how do they talk together, and what is standardization, it really is how are you bringing meshes and capabilities so that autonomous systems can learn more about the environment. And then one of the things we've seen in partnership with Amazon and others as we think about cloud capabilities is there has to be a balance of how do you do this at the edge? Because if I have three things out in a theater, they can't all rely on going back to the cloud, but that doesn't mean the cloud's not useful in these areas. So as we think about that, right, how are we thinking about the training, the capability, the centralization, and the understanding that allows humans to understand the broad intent of what is happening, communicate out to the devices, and then allow that autonomy for them to communicate and carry out their actions together in support of humans at the edge. And then you're also pushing down to the humans at the edge, what was the thought process, intent, and objectives so they can even adjust what those outcomes are. And so I think humans in the loop has to be thought of very carefully from a design perspective in all of these autonomous systems. And it really should augment and make the humans more effective is the way we think about it. And so it's not that you're replacing or removing these things, it's that I'm adding new skill sets, capabilities, and things like that. And ideally, if done right with modern design principles and things like that, you can do that without giant training overheads. And so instead of saying, do I need a core of specialized drone fighters that is the thing that they do, can I enable every person to be a drone fighter the same way they all carry around an M16 or different things like that? And so that is where autonomy enables like a democratization of those capabilities where they're not specialized. So these are some of the things that we're thinking about bringing modern software principles, being able to iterate quickly and deliver these things and do that in a way that is augmenting and enhancing the force and making everyone more effective. So that's the way we're thinking about it.
Yeah, I think the way I think about it too is it's not just about platforms in the field and things flying around and in the ocean, but it's also just about how we're relieving cognitive burden, how we're drawing inferences between pieces of information that a human might not be able to, because it's just like Alex said, it's dull, right? I'm sifting through the same things over and over and over again, and I may miss a correlation because I was up late last night, but that correlation could lead to a significant change in how we might react to something. So autonomy is also agents running across these huge amounts of information that we're collecting, right? We have more information than we know what to do with. We can't store it, we can't keep it, we can't look at it fast enough, and that problem is just going to continue to grow exponentially. So how does autonomy help us make those decisions faster? How does it help us trust the information that we're getting, right? Because if I have to independently validate an assertion that I get from some platform myself, that may be really challenging, and maybe I don't trust that platform or that source a lot. But if I have multiple autonomous agents looking at different things and giving me insights that helps me come to a higher confidence, I can use that information to make a decision. So I think we talk a lot about humans staying in the loop. As you get out from the kind of the higher echelons out to the edge, obviously, like Zach said, we have to think about that. But those decisions are still going to be made in large part, by people who have access to these huge repositories of information. And in the field, when you're making tactical decisions, that's a different discussion. But I think we have a really low-hanging fruit opportunity to start approaching autonomy just in terms of how we're helping people better take advantage of this technology to, again, trust the information they have and make better use of it.
Yeah, just to add on, I think that how you get the right information in front of the right people is one of the things as we explore, even in the commercial sector, as we look at AI agents and things like that with OpenAI and other things, where you see the real power is in how it, exactly as Rob was saying, surfaces the information. And so where at the edge we can bring it back, surface it in the right way. Again, it's an augmentation and an enhancement. And that really is the benefit. And the human is at the center of that, not on the outside.
So I'm seeing the overall themes there is use or establish the role for the human to be maintain the intent of the commander, but at the same time look at that trade space to simplify the interfaces, scale effectively, and then handle the training. The next question goes for Rick Jack, and is as follows. Engineering projects usually consider how systems work from a vertically integrated perspective. However, it's also important to implement design patterns so that the systems and tooling can interoperate with each other. How do the methodologies for autonomous systems change when having to integrate with the complexity of multiple vendors, existing systems, and new emerging capabilities?
Yeah, we think about this a lot. The question is how are we changing the way we do engineering in the future? Obviously, if we did status quo, we would still have a lot of systems that don't communicate, or don't talk, or don't work well together. So if you walk around this floor, you'll see a lot of these conversations about something called JADC2 or CJADC2, which in essence is trying to solve a problem. Like, hey, we have service A and service B that don't really talk well together. So if I'm going to ask ourselves, how are we changing the dynamics in this new and emerging field, I'm going to go back to my first answer, which was first focus on interoperability. We have to change from vertical silos into horizontal ways of thinking. How do we make these systems that can come from many different vendors all collaborate and communicate together on a fairly accelerated cycle? The idea that the data changes, the threats change, the landscape changes. We have to be a lot more dynamic, and so changing to a horizontal mindset relative to how do we do interoperability is going to be first and foremost. I think second is probably a higher focus on open standards. The idea that if we think about proprietariness with some of these things, we need to incentivize open standards. Specifically, like if I'm empathetic towards, say, the Marine Corps, who have the idea that they carry a lot of equipment, and you don't want to have them carry multiple radios just to communicate to X number of vehicles. So we have to solve the open standards so that we can share and communicate effectively, especially with the data coming off these vehicles. That's going to be first and foremost. I think also it's shifting from a monolithic way of thinking to a modular way of thinking. In order to do that, you have to be agile, right? We have to be a lot more dynamic, constantly train, retrain. We were just talking to Fuse about how do we, there's still a problem if we think about, we can throw this buzzword DevSecOps out in front of us. The challenge is parity between the humans who are making these things work and how it works in the operational field. If there's a separation there, we have a big disconnect. And so we have to bring these things together. In order to do that, you have to be dynamic and agile. And if you think about the complexity that we're bringing to this, I was having a conversation the other day, and we asked, hey, what's the command relationships relative to these new things that are coming our way? It was like, well, what's that? We're like, well, if you haven't thought about, we can give X number of vehicles to a specific warfighting set. Like where you're saying, if in a dynamic theater, how does the command change? If I'm entering these vehicles into a strike group, well, what's the relationship between the commands of the strike group and these vehicles? So we have to think of these things, and the only way to think through the complexity is to do model-based system engineering. You have to, a human can't comprehend all the complex situations that go on. So we have to shift from, again, siloed ways of thinking to understanding that the landscape is complex, and we have to put it on into a model to understand how these things would work in the future. Because we can't always test all the various scenarios. We can't. We don't have enough time. So that mindset thinking is how we shift and apply these things in the future, if I'm going to be a lot more of an engineering center focused answer to that equation.
Awesome, thank you. Our next question goes to Alex Zimmer. The discussion on autonomous systems usually considers the tactical edge. We need to also consider how acquisition plays a role with these systems. What processes can be leveraged to effectively procure, scale, and update autonomous systems?
Yeah, so I love this question. When you say the next fight, you automatically think of these vehicles swarming in the wild, combating the enemy, the adversary, and doing what they need to do. But there's a whole process that leads up to that, and that's acquisition. And frankly, our Department of Defense is really good at being reactive and not proactive. That's the way it's designed. There's POM submissions that take years to come to fruition. You get financing, resourcing, you get that to industry, they produce, they innovate, then you have a product at the end of years, past when you actually need it. For the past several years, I've been embarked on this thing called Project Ammo. So I'm very happy to say that. And it's essentially the idea of having a ecosystem that allows the artificial intelligence piece for autonomous systems to adapt at the speed of tactical necessity. So what do I mean by that? So the idea is that we have our defense industrial base back CONUS. They're going to be stateside. You've got your operators fighting overseas. The operators are going to encounter something from the adversary that they've never seen before using their unmanned systems. And in my case, for the unmanned vehicles, they're using automatic target recognition. So they're trying to find adversarial targets. And the operators need to have relevant software that's capable of detecting those targets. And so through Project Ammo, what we're attempting to do is create a AWS cloud-based pipeline that allows our unmanned systems to connect back stateside to the developers that need access to that data. And so the idea is this. Through this acquisition process, you are constantly updating your vehicles. You're constantly feeding in new data products. You have your algorithm teams training machine learning on that, and you've got ATR or some other solution for AI coming over the pipeline, going back to the edge, forward deployed, and using whatever communications pathways the operators have available to them. I think that getting to the next fight is just as critical as being there and having systems that function there. And once we get there, adapting them to the changing environment, which is a part of the fight, is going to be critical.
Thank you. Awesome, thank you. The next question goes to Rob Nolan. The U.S. Navy is going to continue to build traditional weapon systems, deploying on existing and new ships. What are some of the factors to consider for these traditional systems to work effectively and integrate with autonomous systems?
Yeah, so I think first of all, the open architecture conversation is super important. A lot of these things, we have to balance this need to kind of build capabilities quickly and get them out there, but also realize that they're all going to be working together in some shape or form as soon as we do start using them at scale. So how we can take advantage of open architecture, not just to have those capabilities talk to each other, but also account for existing systems. I think Rick used an interesting term that we see a lot when you talk about just general enterprise modernization, which is seams. So the idea of building in sometimes maybe temporary or even redundant things that give you the ability to interconnect stuff, right? So are you going to spend a whole bunch of time building a specialized interface for every single system you onboard into the fleet, or are you going to build one common interface that talks to a traditional weapon system that also protects that, right, from other, because you're going to have all these things wanting to pull data from it, and I'm not even thinking cyber, I'm just thinking maybe you DDoS it, right, because you have all these different tools trying to get tracks and information from something. So build things in that help you more rapidly integrate while still protecting that traditional system to let it do its job. But one thing we've learned over 8 years of doing cloud as well is integrating it into training and doctrine early on. I think, again, with cloud, we moved really fast, we showed a lot of value, and, military tends to move quickly. You move around, you do different jobs, you try different things. We train people all the time. But how do we start building this in so we can start teaching people from the beginning, right? It's the same as you teach any other basic concept when you go to basic training or you go to the schoolhouses. I think we have to have standardized environments to test this integration, to simulate this integration, and to do training on it. the first time you see something shouldn't be out at an exercise when you're connecting all these things together. And the concept of how these things connect together, I think, has to be really carefully thought through and built in a way that you can simulate it in virtual environments quickly. And then by the time you get out to actually touch the real hardware, you're just getting a feel for how it integrates into your workflow, and you're not trying to learn how this component talks to that component, and we're not troubleshooting those seams and those kind of things. So those lessons can be applied for anything, really, and we've learned a lot of those the hard way as we've been trying to bring new and modern technologies in with cloud. So I think the faster we can get kind of a domain of practice around that now, as these things start to roll out, the easier it'll be to adapt them at scale for when they're actually needed.
Okay, thank you, Rob Nolan. The next question is for Alan McAfee. With the rapid advancement of adversarial capabilities in autonomous systems, how can we ensure our autonomous systems technologies maintain a competitive edge while remaining secure and resilient?
Yeah, so I probably represent the smallest organization at this table. We started 14 years ago. We grew up through SIBRs, bootstrapped, so we were very much used to working with the warfighter. That's what's within Fuse's design ethos. We talk to the warfighter first. We make sure we understand what their needs are. But that's nice to say. And then once you start getting into that integration layer, so after we develop the capability, after we bring it to the customer, and we have to get it into a lab. We have to go to NavAir, have to go to NIWIC, start integrating into their environments. We reach that vertical integration issue that we've talked about in a couple of the other answers. So as we're talking about a pathway to production at scale for autonomous systems, if you're not as big and well-funded as Anduril and can make your own environments and have all of that sponsorship to get what you need, we really need reach parity between the industry and government cloud environments. So my team does not have to wait to test within the Navy's environment, for example, to find the bugs that we're going to run into issues. So as we said before, that by the time we get out to the exercise, that's not the first time we're seeing certain issues. So we're very used to AWS EC2, but sponsorship and championing of small businesses getting access to those environments is sorely lacking. I definitely think we need to put more emphasis on that. And then as we're talking about cybersecurity and resiliency against our peer adversaries, RMF framework is great, but it's a static exercise. It's a snapshot once in time, just to see, did you cover the basics? One of the things that I found most enriching from my time at Fuse was my time during the Mudland JCTD. We were the first JCTD to actually sit down at a cyber range and do a cyber tabletop, and we learned so much. That learning, 4 or 5 years ago, has influenced so much of what we've done since then. And what I am remiss in seeing is we don't really do a whole lot of red team exercises in the cyber domain. So we get out there, maybe we'll do some EW stuff, maybe we'll try to break some links, but as far as the integrity of the systems and what we're building, I definitely think there needs to be a sort of mental shift in what cybersecurity really means as we're deploying more of the stuff to the edge. The DeepSeek announcement this week come from China, scared a lot of the industry. You saw NVIDIA tank pretty deep. That's just off news. That wasn't off of any, a whole lot of other information outside of a claim. So as we're watching the capabilities of our peers, it's really important that we ask ourselves, I like the AWS way of thinking of this, or the Uber way of thinking of this, how do we suck? Where are our deficiencies, where are our gaps? And really get into a collaborative mentality where we're checking each other's work and trying to penetrate, the systems that we're actually deploying. And furthermore, the one thing that I do not see actually covered in a lot of our work is supply chain risks. So if we're going to get attacked with especially group 1 to group 3s, and I'm not going to touch the 4s and 5s because traditional contractors really have those programs nailed down, but as we're working with the smaller systems, the smaller drone systems, the vulnerability is there, and the checks and balances on how we're going to overcome those are not openly discussed. That is not a part of the RMF framework itself that is routinely revisited. And I do think that's going to be a risk that we need to address going forward. So balancing the rigor and all of the engineering that we're doing. Rick had mentioned MBSE being a critical component of how we make sure that all of these different groups are integrating correctly. I absolutely agree. There has to be a common language between programs and engineering, and the open Dagger environment's great for how we're procuring software. But I think that's just a start. We really need to start moving it towards the mindset of horizontal integration and figuring out how do we leverage cloud in just the right way, but also get into the real system so we can root out all of those issues before the fight actually happens.
Awesome, thank you. I like how you tied that into the horizontal ways of thinking Rick Jock brought up. And then I also feel like it ties into Rob Nolan's integrate into training and simulation environments quickly. The next question is for Zach Kramer. In terms of data integration and interoperability, what approaches have you seen be successful for autonomous systems to effectively communicate and coordinate across different service branches and legacy platforms?
Yeah, this is a huge challenge as we look at it, and I'll start up front with it. We definitely, as a collective across the DoD and industry, have not figured all of this out. There's a lot of work to do here. I want to harken back to something that Rick Jack was talking about around the question of how we think about our ability to innovate while maintaining systems and integration. And so Anduril's a startup, values going fast and getting things done and autonomy within that. So even within the corporation, there's a lot of how does each division and each capability go fast to do the things that they need to do. And so we actually have had to tackle that problem internally, which is how do I give whether it's our dive ecosystem doing underwater vehicles to Fury and planes to Sentry towers at the border, how do you have those things still be able to talk to each other and interop without slowing down the development and iteration? And so we've done that with our kind of common software platform and said, okay, you can interface at those layers and bring that together. And so my role is really how do I exist at a company that builds physical things and be the one that delivers the software, right? And so it's a bit of a funny position to be in. And so what we've seen is integration is the name of the game, right? And so my team has done a bunch of work on how do we go look at legacy systems and think about those. And it really is how do you get the information off and bring information to those systems to allow them to inform new capabilities. And so as we look at autonomous systems, can legacy systems be made better by giving them more information that can enable them to make better decisions? And then how do you think about the transport and integration across services and other capabilities? One part of that is policies and willingness to be able to talk and interop. So we talked about whether it's accreditation policies, that we were talking about or other things. How do you have those system interconnects and ability? And so we, with CDAO and some others thinking through kind of how do we have, DoD-wide capabilities that can be leveraged for those integrations. And so that's where we've been working, across with cloud provider partners and with others, Palantir and small partners on how we begin enabling those integrations to have a common transport layer that brings the things together, but allows that independence of the interfaces. And so that ability allows us to have both common capabilities of integrating with legacy systems, enhancing data to new systems, and then enabling common transport where the right data can get to the right capabilities. And we've seen this in different places where we're able to bring, Marine sensor data or Army data or transfer those back as the Navy thinks about how they plan a mock fight or different pieces like that. And so having those come back together does really inform and drive new decision-making processes, which we think will be important and powerful for the future. And so that interop and those capabilities of having that platform has been something that we certainly have invested in and see that as a critical component as we go forward. And then how that data comes back to a cloud environment or to those capabilities to be able to then reason over, perform AI, and do other bigger things that don't happen at the edge. We think all of those things are important as we look at that interoperability and connection.
Awesome, thank you, Zach. Can I deep dive on that one just a moment?
Yeah.
So when you say common interfaces, do you think that's generally covered by well-documented interfaces that you can provide to other systems, or do they have to be open sourced and developed by an entire community?
No, and so what we've done is we've had experience as you think about it is how do you build integrations that meet the systems where they are, and so there's a reality of saying I would love, it'd be great if we could replace everything and modernize it and everything could have a nice, well-defined REST or JSON API that you could hit, but that's just not the reality of where we are. And so the way we've thought about it is, how are you building those integrations that are unique to those systems in whatever way? It may be, how am I pulling data off of a diagnostic port on the back of a machine, but then turning it into something that is modern and capable so that I can integrate it with the mesh? And so you have to have a lot of flexibility at the point of ingesting from these systems, but as soon as possible, getting it onto a standardized mesh or capability that can then move that data and surface it. And so, as Rick was saying, like, how do you think about the layers and the horizontal capabilities? So I can have a module that can translate this legacy system into something modern. I can then have a transport layer that moves it around and surfaces it to the right systems, COPS, or other capabilities. And then I can even have integrations that bring data back into those systems where they support that.
Great, thank you for the clarification. So the next question uses the term OODA loop, one that many military folks in here might be quite familiar with. Observe, orient, decide, and act. And the question is going to go out to all the panelists. We'll start with Rob Nolan. How might the integration of autonomous systems change the traditional military decision-making cycle, also known as the OODA loop, and are our current workflows optimized for this solution?
I think it's going to make it faster. It's going to make it faster. It's going to give you the ability to consider more things at once. The scenarios that people are going to have to evaluate are going to move rapidly, and they're going to be dynamic, and they're going to throw all kinds of stuff at you that you just can't simulate. Things will fail, things won't work, you won't be able to talk, you won't be able to do this, you won't be able to do that. So I feel like it's going to have to move faster. And so the autonomous systems we're talking about here are going to give you better insight into what's going on. They're going to give you tons of information, but then they're going to have to help you boil it down so that you can actually make a decision. Depending on how things change, the course of action to get the desired effect is going to have to change. And in the world that we're talking about, by the time you make humans evaluate it and pull together a slide and go have a conversation, like, it's long past time for that effect to ever happen. So we have to get ourselves in a position where we have things that we can trust, that give us good insight into good information that we've vetted, and we have a good understanding of the provenance of, and we have a clear chain of how we derive that course of action, and then make that decision quickly. I don't think we're at a place where we're going to be delegating like actual effects to machines just yet. So the slowest part in the loop is going to be the humans. So we have to optimize and take out all the variants and get them to a place where they can make an intelligent, well-informed, rapid decision quickly and be able to explain that. So to me, that's probably the biggest benefit of what we're talking about here, and whether that's using a platform or just using software to inform that.
I think Rob stole my answer, which is speed. I definitely think speed is going to be the factor that changes the most in the future. With that comes complexity. I strongly feel that yes, things will get faster, but things will become a lot more complex. And so in doing so, I think in the future we're going to see shifts in concepts and ways we employ these things. There's kind of this ebb and flow between a centralized mindset and a federated mindset. I think if, like what Zach was saying, we make these things simple enough, we've now empowered a force of junior sailors and Marines to be their own command and control structure, so that you're going to see a lot more dynamics in the battlefield, and the power of using these things in more of an asymmetric way is going to be the here and now. So not only are we going to have faster decision cycles, but we're going to have to federate that downward in the command and control structure. Yeah, you'll ultimately still have commander's intent. That's still key to command and control, but you're going to allow different ways of using these things to give you the competitive advantage that we're going to see in the battlefield.
Yeah, the autonomous systems open up new opportunities for exactly how you express intent, how you make these decisions. But when you come up to the highest level of expressing things, what is interesting is what we're really kind of competing to unshift is how do you break out of like PowerPoint? How do you make something that's easier, faster, and better than creating a PowerPoint slide? Now, I worked at Microsoft for a long time. Like Office is great, like an incredibly powerful tool that offers a lot of flexibility for people. But to really enable you to look across the battle space at machine speed, it's not going to work to put it on a slide and brief it up like that. And so as we look at the software that is required, you start saying like, I need cloud scale solutions that allow me to understand, build things, and drive capability. You also need to be able to look at and do those same things at the edge so that you can democratize decision making, as we're talking about. And so I think you really will see changes in how we're making those decisions and how we're surfacing data so that we have systems that are built with the, sailors and everyone in mind to be able to say, how do I surface the right information for quick decision making, allow that person to express the intent of these new capabilities that I have at my fingertips, and then allow them to scale out across the battle space, and understand that I may be making a decision. The other thing we focused on is how do you get enough information to be able to make the smart decisions there? We recognize very clearly that you're never going to have perfect information as much as you would like, right? Everything's not going to come back together, fuse into one single picture, and get back out with the speed of decision making you have. And so at the edge and at those capabilities, how am I giving you the right situational awareness of what's happening, empower that decision making, and then allow the vehicles to do that? And so as we think about autonomous systems, they talk to each other and understand what's happening around each other so you can have actual mission autonomy, not just autonomy of a vehicle. And then how does that all surface up as you look at the broader strategic levels of autonomy and things like that as we surface out? So we've really been kind of playing around with some of those things as we look at that and understanding what are the things that work and what are the things that don't work, and then how do you bring information in? And it goes back to legacy systems, it goes back to systems engineering and those capabilities to be able to stand up that integration and those pieces.
Yeah, so I guess the way I see it is from two different minds. You have, Fuse specializes in modernizing legacy platforms. So our goal is, if you used to just have a UHF radio in your aircraft, and that's how you were getting your command and control information, how do we improve that? How do we get you JREAP-C, for example? So a lot of the autonomy that is currently in implementation from the human user perspective, are things like track correlation, these nice inference engines that help sanitize a situational awareness picture for the user. Okay, cool, but that we can still use the old school OODA loops for that kind of decision making. When we're looking at swarm control, all the fancy stuff that we're looking at on the horizon, I'm going to go back to the sort of the nested OODA loop description that I gave at the start of the talk. The semantic gap between machine and human understanding is wide, and there always has to be a human in the loop there. So the decision tree is going to obviously always follow commander's intent, but as we get closer and closer to the engagement zone, those OODA loops are going to be faster and faster and faster. Humans are going to be slower and slower and slower, and it's going to fundamentally shift how we're interacting with machinery that we're using at the edge. So again, I think that we have the capability to make the right ethical decisions, prevent a lot of the worry that we have on what those machines making decisions at the end, because they're going to have to be tightly controlled with pre-approved execution parameters. Because it's hard enough to control humans, in a heated environment. So how are we going to control machines who have, pretty shitty awareness on what's going on around them? We get past that, we get to a state where we're trusting the machinery that we're actually using, and I worry at that point we start offboarding more and more of that decision making to those machines. So I think we always need to keep humans in the loop, always need to make sure that at least at the strategic and tactical levels that the humans are first, that they're being augmented by these systems.
When Mark 18, the Unmanned Underwater Vehicle Program, went through the OSD Fastlane initiative over a decade ago, the ethos was get the man out of the minefield, use the robots to do the dangerous tasks. And at a strategic level, to answer this question, an operational commander has to essentially, he's responsible for the, his or her troops, and he has to accomplish some mission. And he's making decisions based on the information that he or her has at that time, and he has to weigh those decisions. And so that type of risk assessment is a constant factor in the next fight. And I think that having autonomous systems at your disposal allows you to essentially make easier decisions. Send them into the really tough situation, don't risk the lives unless you absolutely have to. So I think that's where we're going to see a lot of change there. At a tactical level, we touched on a lot of this already. Right now we have a lot of operator in the loop systems, and that's going to change it to operator on the loop systems. We're going to have heterogeneous systems operating together, and we're going to have more of a leader-follower type situation. The way I like to think about this is we've all had that one manager that's a micromanager in your business every day trying to track what you do at your job, and frankly, they can only do that for so many people. It's very inefficient. But as we start improving our command and control, these autonomous systems, we're going to have sailors at the tactical level turn into leaders. And they're going to distribute intent to the unmanned systems that are going to follow that chain of command. And so, together, I think we're going to see a lot of changes that affect this OODA loop, that allows us to move faster, allows us to have more capability, and essentially create a more robust system for the next fight.
Great. So I like how everyone here kind of took their own spin on it. We need to have decisions faster, boil down the right information in the correct format, get the right information to the right person depending on their role, make sure it's trusted information, and then how to do it at scale. So that's all great data points for that trade space. So we do have about 10 minutes left. We've got the whole panel here. Is there anyone that has a question that they'd like to ask the panel? Pretty open. Anybody thinking of a question?
What's your favorite color?
Okay, we got one. Oh, there's the mic. I'm sorry.
Hi, good morning. So considering all of the discussion today and the understanding that training needs to be done faster and standards need to be identified, right? Is there going to be a DoD standard for the human-machine interface, physical or graphical person communication, right? So being a person who's used Windows most of my life, having to go to Red Hat, which is the current system, it's not intuitive. Even going from an iPad to an Android, right? It's not intuitive. So my question is there going to be a standard on the human-machine interface, graphical interface, so that when that guy who falls down in the field and his buddy has to pick it up and he's been trained on how to use it, is it all going to be the same? Or am I going to pick up one thing that's going to be graphically presented one way or graphically presented another? I'm going to go, oh, crap, how did I hit shoot or whatever, right, on the one pad versus the other pad? That's the one standard out of all the discussion I would see would be something that would allow a sailor to pick up a soldier's, tactical device in order to then control the unmanned vehicles. So,
I'll take a crack at it. What was your name?
Joe.
Hey, Joe. So the simple answer, I know Joe, by the way. Simple answer to that is no. But you did tip at the way you address that, which is intuitiveness. So I don't know if we'll ever get to a place where there's one that conquers them all. I think there's somewhat aspirational ideas that you're going to have the king of interfaces that addresses everybody, because even in society today we can't really agree on Android or iPhones or whatever. But why people gravitate to those things is they're intuitive. And so I think to address that concern you bring up, what we need to do is drive more of a UX mentality and push our performers to deliver intuitive interfaces that mitigate the need to have to train things. That's what I would do.
I'll take a crack at that too. Fuse has its own UI. It's called T3, Technical Technologies Toolkit. We're the network cop, if you will. So we want to make sure that the JICO, the operator, understands what their network environment looks like. It's very pretty. Lattice is very pretty as a C2 application. But I think that's kind of the challenge, is that every vendor has their own UI. And what I've been very encouraged by is the TAC family of UIs is really, really spreading its adoption rate. And I think that if we're going to aim for a common UI, which I think we should to really reduce that cognitive overhead, is build into these government-owned UI systems. And TAC was one of the first government-sponsored projects. I was like, oh wow, you guys really nailed it on that one. It could be prettier, sure, but it runs really well on really old devices, and it does everything that the user needs to. So why don't we all integrate into that? So, Fuse has taken the steps to integrate into ATAC and WinTAC, stop trying to sell our own, pretty UI as the only way to interface with our systems. I really think that I see a lot of other vendors marching to the same angle. Again, though, Lattice is a horse of a different color, though.
Yeah, no, integration I think is key. I also think how we think about scenario-based user experiences. Like we certainly have thought that there's not a singular user interface, so we start from SDKs and other things that you could integrate with and pull into other things. And so if you're, fighting or taking care of one thing, like how do you have some commonality across those scenarios, but also not constrain whether does a logistician versus someone driving a drone versus some other capability need to all look at the same user experience? And so there's enabling variety where it makes sense, and then driving standardization across key scenarios, I think may be the approach versus a singular experience to rule them all.
Yeah, I think that's also where the seams comes into play, right? There's going to be intermediary layers that I think we are as industry going to have to build. I think TAC is absolutely the right answer to start. We go to conversations where we get told by people, stop trying to give us hardware, stop giving us another thing to carry, just make it work with what we have, right? If you look at you look at the stacks the Navy brings out, whether it's expeditionary on the ships, or what the Marines bring, or what the Army brings, right? They already have a bunch of computers. They already have a bunch of things they're bringing with them. It's another thing they have to fix. It's another thing some guys got to carry with them. So, I think a lot of what I've seen from Lattice and some of the other C2 systems is they are very API driven. They can put a dot on a map. What map that is, I think that deep integration with the user community is super important. And so I think the user community surfacing it and us getting out there with the users and getting into exercises and watching how it breaks. Early in my career here, I remember I asked an old tanker guy, because he mentioned, he was talking about the stuff that he used when he was going into combat and how much he trusted it. And I said, how did you get to a place where you trusted it? And he said, the vendors came out with us at exercises, watched it break, then came back with the next one. And you see that, right? You see that at Project Convergence, and you see that at Northern Edge, and you see all these places, like, we're bringing our stuff out, we're trying to make it work. So give us that blunt and honest feedback when you see these things show up. I can't use another UI. I've already got 6, or I need this to be simpler. Force us that way. In addition to the programs putting requirements on us, I think it's sometimes more powerful to hear it from the users than getting a requirement. Because by the time it gets through the chain of requirements, writing, and the legal stuff and contracts, what you said has been completely warped into something very different that makes it more expensive and harder to push. Then you end up with another iPad. So I don't know.
I'll answer pretty quickly because we have some more questions here, but I think what you're going to see is consolidation across different classes of unmanned systems. So for small, for example, that makes sense. We have TAC as a great example of a system, or a C2 for that element. But you don't necessarily want that sailor to pick up a control and have access to a frigate-sized unmanned system, right? So I guess my short answer is, I think you'll see consolidation, but across various sectors of unmanned systems.
Yeah, let's do the next question. So we have to...
No. There we go. Okay. Justin with the DoD Inspector General. So quite often what we've seen, at least or proven in the last 15 to 20 years, is that we struggle with cybersecurity. It doesn't, a day go by, you don't read about a new problem that has occurred. You bring us new capabilities and they're almost immediately stolen. It happens all the time. Now that we're talking about unmanned systems, what steps do you guys think are important for us to take to make sure that these systems are secure, can operate in an extremely degraded environment with potentially very limited C2 of the systems that are out there operating? Thanks.
And for context, we have 2 minutes left.
A quick answer to that. So the way you do it is red teaming. So we could try to shift left on engineering and design the most secure systems, but sometimes we are struggling with outpacing obsolescence. The CVE report just came out. The projections do not look good. Most software in the DoD ecosystem will not be able to compete relative to the amount of vulnerabilities that exist. So the way we have to get after it is prioritization and focus. And the way you mitigate the issues you're talking about is focus on the important things and address those, and then mitigate the others by abstraction. Red team.
Go red team.
Okay, we'll try the last question.
Hi, Alex Bertram with the Government of Western Australia. I wanted to ask you about interoperability. Strong mining industry in my part of the world, high degree of autonomy in haulage, yet the incentives haven't aligned for interoperability between systems provided by OEMs. So there was some good discussion on needing incentives. Keen to hear what that can look, what dynamic you see, and what those incentives need to look like to actually drive interoperability between autonomous systems. Thanks.
Did you guys hear the question?
Yeah.
Okay.
I think there's a couple things. So I think there are elements even in the procurement layers of like how do we think about making sure that there are open standards and open data that would enable interoperability through the system. So we've certainly seen some of that stuff. And then on the second side, it's really like how do we begin thinking about how systems get better through interoperability so it actually becomes a competitive market advantage to the system. So we've been trying to push and champion some of those things as we think about it so that it, why, a system and a change, like why would I build a system that doesn't leverage the systems that are around me and I get smarter and better and then have better opportunities. So it's a mismatch of a multiple approach of both how we think about the commercial companies thinking about things differently from an incentives perspective, and then how do you push some of those, making the data available so that it opens them up to have the opportunity to do it.
Yeah, I think that you being from Australia, you hit a bigger problem with interoperability, which is like it's not just the machines talking to each other, but now it's the policy apparatus, and it's how do we just share, like, how can I send you an email, right? Like, I think that one sometimes can be tricky. So I feel like a lot of what we're doing with AUKUS is going to help that in terms of just kind of setting common technology baselines. And as we start to expand the scope of something like that, and including more and more of the autonomy, and again, not just the platforms, but the software and how we interoperate these systems is going to be important. I think as we speak right now, there's an MPE conference going on in Hawaii, right, where they're trying to figure out a lot of that stuff. Because in order for us to interoperate our systems, we have to interoperate our data and have those conversations. So really hammering that home as policymakers are trying to figure this out and getting us to a point where we have the ability to expose these policy gaps quicker in exercises and in actually putting these things into practice. Because it's easy to go to an exercise and have a bunch of smart guys sitting around exchanging cables really quick to make it look good. But we need to get this more indoctrinated in how we actually build these systems for deployment and not just for an exercise and a demonstration for DV Day. I think that's going to make the policymakers realize they got to push harder on some of these blockers.
Awesome. Excellent question. So we're going to wrap up. I want to thank those folks that were brave enough to ask a question. Those were really good. And then I want to thank each individual panelist up here for sharing their insight, experience, and time with all of us. But with that, thank you for coming. I hope you found this valuable.